Thanks so much for joining us for our last podcast today at DesignCon 2023. Today I'm joined by my ex-employer, actually, and good friend and colleague, Chris Savalia, who's the CEO of Transline Technology, and also his talented production manager, Madhur. Madhur, I'm sorry, what's your last name?
Chawla, C-H-A-W-L-A.
Thank you. So we're going to talk a little bit today about what engineers need to know about RF, microwave, and millimeter wave printed circuit boards. And I've had the privilege of working with Transline very closely and learning so much for them. So, gentlemen, I'm so glad to have you. Thanks so much for joining.
Nice to meet you, Judy. And we are back together now.
We are back together again.
After 5 years.
So,
when was the last time you started? 2010, right?
Something like that.
Yeah,
it was a long time.
It was a long time.
Yeah. So I didn't know anything about RF microwave, and you didn't know anything about marketing. So we were the odd couple, but we did a lot of good work together, and I think we taught a lot of engineers things that they needed to know about how to successfully create RF and microwave boards. And I used to write blogs and tell engineers what you don't know will hurt you, right? And so I was eager to have you both on today to talk about how far Transline's come since the time that we worked together, and also what additional services you've added, actually. And one thing you've all taught me is that RF, microwave, and now millimeter wave boards are quite different, not only in design, but also in fabrication and assembly.
Yes.
And I know that you added services that help engineers sort of navigate that whole sort of ecosystem successfully.
Yes.
So, start with you, Chris.
So mostly, first we always start work with the design engineers. When they started designing, the selection of the materials and everything, numbers of layers, try to make it easier, manufacturable, and all the material process difference. We start from there, then we start fabricating the board and follow all the standards and make sure they get the performance that they want, they need it. And then
so I know you're on the production floor.
I know, like basically as you were asking about the radio frequency, like RF and millimeter boards, the millimeter boards are basically, they're very different. The material used is very different than the regular digital and the power boards like we usually used to make it 20 years back. Those are like FR4 boards. FR4 boards are basically like a low-cost boards, and the laminate used for these kind of boards are really, really expensive and a low loss. You have a special like manufacturers for that. You can't get it like there's a long lead time sometimes on those kind of materials. Mm-hmm. So we have the new addition to our company is like we have a team. It's called DFMA team. That basically it's a design for manufacturing
and assembly.
And for assembly also. It's for basically to help the engineers, those who are designing the board, which the board is usually in a design process. Mm-hmm. There are basically two stages for the design. One is like a design progress stage, and the second step is like proof to the concept stage. So first you are designing. We always encourage designers to contact us while you are designing it, and our team basically get in contact with you, work with you on your laminates, on your assemblies, on your basically while you're designing it, like your copper thicknesses, your etching factors,
number of layers,
what components are available, because there are many problems going on in the world, like cost prices. Like there is a problem of like supply chain,
everything.
So like our Transline has a second thing is, other than the DFM, we have a $1.5 million of inventory.
Of all the laminates.
All the laminates in-house to help those design engineers. While you are working on the design, we are working for you on the other sections to get the material, to make, or suppose if the material is not available, I will let you know. Like, hey, this is gonna be the use, this is gonna be like that.
Or we can recommend the optional other material.
Yes.
So similar material, and they can evaluate.
And we are a kind of a shop, like we want your product to become in the market as fast as possible. I don't want your product will not see the light of the day.
Right.
And it should be performed the way you expect to be performed.
Right.
Right. And there's a lot of things that board shops, board fabricators can do, like some of engineers have told me that they swapped out the laminate without even telling.
They don't even
They're
tell
like, oh,
them.
this is close
No,
enough. And it's like, what do you mean? And the engineer may never know that the laminate was swapped, but it has different properties.
No.
And they've simulated it during the design, and then they get it, and it doesn't correlate at all. And they're like,
what happened?
What happened? And then we call it whack-a-mole, right? They're like, is it this? Is it this? Should we move the capacitor? What's the, you know? And
we always inform the engineers, all the engineers, it's not available. This is the optional. Evaluate, then we can start working on it. The end of the day, the result it's about the performance of their product.
And I know when I was working for you way back when as a salesperson, you having all those high-performance laminates in stock was such a big deal because whether it's Rogers, Taconic, Arlon,
AGC,
all
Isola.
of them, it just depends on, and like you said, it's been really unstable globally.
It is.
Sometimes the copper.
Trust me, we have like a lead times of 35 days, some of them.
60 days.
60 days, business days. So
but
what
we
we
keep
do
it in a
is-
stock.
What we do is we keep all those laminate in the stock.
Right.
We actually, that's what our job is. Like while you are designing, we always encourage people while your design started, because design take weeks, sometimes months.
Yes, it does.
So it's not going to be an overnight design. You're going to make it like in a day and you're going to send it back to me.
Right.
So I will say, encourage the engineers, hey, whenever you are starting the design, contact us. We're going to work, we're going to do our homework.
We'll check if the material is available or not. If not, then start with a different material.
And recommend it and know that the properties are going to match.
Yeah.
Yes,
And you're going to
yes.
also have the insights to know how it's going to process.
100%.
The processing is very
And
important.
the processing part, there's so many factors of the moisture uptake, the way the stability, and especially a lot of engineers make hybrid boards, right, where they're mixing
Yeah.
materials. But you guys have been doing this for decades, so you know how they perform. And I used to get so frustrated, like, talk to your board shop, right?
Yes.
And so
they pick one layer of material and other layer of other material, and the pre-pack is different suppliers, so it's no material supplier support you. So we try to encourage engineer to use one supplier for your whole stack up.
right, because then they work
Then
together.
we can get the technical support from the one material supplier.
Got it. Well, and I know that, and like you said, the pre-preg, the type of glass weave they had, and you taught me a long time ago about the way you had a special cleaner in the shop.
Yes.
And you taught me, we're always talking about copper surface roughness in regards to the material,
Right.
but then also just the way that a standard manufacturer cleans a board can affect the way the waves are moving, and it changes the property and performance of the board. Again, something that typically, unless an engineer is working with a board shop like Transline, they'll never know, like, why isn't this performing? I designed it this way. And it may just be something as simple as the way the board was cleaned.
It's very important before all the process. The surface preparation is very, very important, and it's different for all the material. It's not same standard.
Yeah. It's not like, Rogers, it's all like this.
it's
No,
not.
it's every single, and then there's copper types, then there's reverse treated, and then
all
there
different
is
things.
Different for
rolled
even-
annealed, and then there's
One of the customers sent me a RFQ. There was 4 different material supplier in the one board, one stack up. So I started calling all 4. They said, okay, we can provide you information on our product only.
right.
So they end up changing the whole stack up and went with the one.
Right. And they also, when it's made by the same manufacturer, those laminates have been tested to
And
work
they will
together
behind you,
as
they will
well,
support
and
you
they'll
all the time.
support you.
Yep.
So
That's-
again, there's so many things. Again, I always feel like I'm trying to help engineers
talk to us.
Yes, talk to Transline or talk to your board manufacturers.
Talk to your board shop
yes,
before
talk
you do
to your
anything.
board shop. And I remember one of my happy moments was I was calling on a large military prime, and they actually called me during the design phase, like while they hadn't finished laying out the board and they wanted to do something with a cavity and some materials, and they called me in, and I sat there and I said, I can't believe you're calling me during the design phase. I write this blog on Microwave Journal about talking to your supplier. She says, I know, I read it. That's why I called you. I was like,
great.
Yes.
And now we added the next step, not only for up to the board, we also go one step ahead on the assembly side of it. Once the boards is done and the components is not available or long lead time, then what good the boards are? It will sit there.
Okay, so you've added those assembly services.
Yes.
So you're looking across the whole product.
Turnkey project.
We also asked the design engineer to provide us the BOM with your design or board files.
So
I mean,
you
even
help
if you don't,
with the BOM? Can you help? Like, wonder if this happens often. Is that the part is available when they designed it, but then 3 weeks later it's not.
But then get ready for another alternate parts.
Okay, so you help them identify sources so they don't get to you and say, oh, sorry.
Because that, after this COVID thing and everything, the supply chain and everything.
Yeah, we always have a cross.
It's not only up to the board.
Yeah.
It's supposed to go to next step.
Right.
Yeah.
Otherwise, boards can sit there for a.
They're forever quarantined over there forever.
Yeah.
You're not gonna use them, you know.
Yeah.
So we want them to use it. So we got all the kinds of like components and everything. And
even if you don't do assembly, it's fine. But we also support. We have sister company who does the assembly. So.
Okay.
Yeah, we support the assemblies too now. So it's a
so
next step,
engineers can pick and choose
whether they want to take it on your own or we can help them, and we don't get involved. Once they agree with us, we get them in contact with our sister company, and they deal directly.
So as you look ahead sort of the trends of RF microwave and millimeter wave and the boards that your customers are sending, what are the technology trends that you're noticing?
It's getting tighter and tighter, thinner and thinner, smaller
in the tolerances.
But we try to, sometimes it looks so beautiful on a screen.
Yeah.
But
when it's blown up this big, right?
20 times or something.
Yes.
But that's not.
It's like a difference between ideal and practical situations. It's
Yes.
very nice to see on the screen.
Yes.
But for us, it's a manufacturability, so we have to manufacture it. It's becoming really tight on tolerances, but still, I will say it's manufacturable up to a certain extent. Like if somebody asks for, I will say like up to 3 mil line, 3 mil spacing. Yes, Transline can do it.
Right.
It's not a problem for us.
But sometimes, why make it so complicated if they can get the same performance by making the design easier to manufacture?
Yeah, and sometimes, I know because of working at Altium, is sometimes engineers would tell me is they go into the design rules and they put a design rule like click all.
That's it.
Yeah.
Right? And then all lines become 3 mils or whatever when the design doesn't need it. It might just need it in one breakout region.
Maybe for a 1 inch or 2 inch area, and they put it on the whole layer.
So what it is, that's why we want the engineers to contact us, so we can help them. Because if you make it tighter tolerance and all this is gonna make your board expensive. We want them to have a good pricing and everything, so go by a proper way of design and everything, so you can have your board in the budget also.
Lots of board, for example, this only small area is very, very important. Other than that, everything is common, normal.
Right.
So we even ask the design engineers, just let us know, circle it, which area is most important.
Most important, yes.
So we focus on that area most, not the whole board.
Right. Well, I do think that sometimes the design tools.
Right.
It just does whatever it does.
Sometimes it's so powerful.
Yeah.
And again, I think the benefit is that, just staying in contact with your board manufacturer, assembler, and having that old-fashioned relationship and partnership. And that's one thing that I've always appreciated about Transline is they care about their customers. They work together to give them the best pricing, the best turnaround, and so engineers don't have to be chasing their tails and wondering why what they simulated didn't come out. And I know you've also, Chris, in recent years, because I came to see you recently, you've added all kinds of new equipment.
Kind of. We just got a new LDI last month and all kind. We also have one large format drilling machine that can drill and route 48 by 48 panels.
Yeah. You do some pretty large antennas for some of the primes.
Some of the primes,
yes.
And which are the craziest
we still do
things,
it.
Which are harder than you'd think, because holding those tolerances across 42 inches
and a 5 mil line or across the board.
Each antenna, if I remember, that each antenna has like 74,000 elements.
Yeah, we counted
74,000
elements. You know those rectangular squares?
Yes.
It was 74,100 something elements.
Yeah, I'm just giving you a ballpark idea. It's like 74,000 elements in a one board.
And
we have to inspect
one of the customers says, okay, can you do CMM on 74,000 elements? I said, okay, yeah, it will cost $75,000 per board.
Yeah, right?
$1 per element.
Yeah, well, that's where people get like, okay, maybe I need to talk to you first before I design these crazy things,
right.
Yeah.
So smaller, tighter, cheaper, all of those things continue to drive your business. Well, thank you so much for you both coming by and sharing your knowledge, and you hold a special place in my heart because of our history together.
Oh, thank you. You are too.
Thank you. You could say you knew me back when, right? When I was in the trenches hanging out in plating rooms and stuff. Well, thank you so much for stopping by. It's good to see you both, and wish you the best of luck and continued success for you and your customers.
Right. Thank you.
And this has been Judy Warner at DesignCon 2023 with my friends from Transline Technology. We'll see you tomorrow at DesignCon.